A ball is kicked from the top of a building. Its motion can be described by the function h at t equals negative 7t squared plus 56t plus 14, where h at t represents the height of the ball at a certain t, or time, in seconds. If the ball lands on the ground at about 8 seconds after it's kicked up into the air, what is the vertex of the ball? So what is the ball's max height? And when does it reach 40 meters? Taking a look at this diagram, let's say that there was a boy standing on top of a building that was 14 meters tall. We know that it has a height of 14 meters because 14 is our C value. Anyways, he kicks the ball and it goes up and up and up until it reaches its max height and then falls down to the ground at 0 meters. This highest point is of course the vertex, so it'll be a point with an unknown x and y, and also we know that the entire thing will take place within about 8 seconds. First, let's take a look at our equation, h of t. It equals negative 7t squared plus 56t plus 14. Right now it's written in standard form, which we don't want. We want it in vertex form, so that we can extrapolate the ball's max height and at which point it occurs. To turn this into vertex form, we're going to want to complete the square. To do that, we're first going to divide these first two terms by negative 7. This equals negative 7 times t squared minus 8t plus 14 outside of this bracket. Next, what we're going to want to do is take our b term, negative 8, and divide it by 2 and square it. This gives us 16. Now we can't just get 16 out of nowhere. In this bracket, it's just like saying plus 0. So we don't just write plus 16, we also write minus 16. But we don't want this number in this bracket. We need to take it out. But before we do that, we need to multiply it by negative 7 because it's still in the bracket. Taking it out, when we close the bracket, we get plus 14 plus 112. Now we can factor what's inside the bracket, and so t times t is t squared, and two numbers that can multiply to get 16 but add up to get negative 8 are negative 4 and negative 4. Since these numbers are the same, that means that we have a perfect square, and so we write negative 7 times t minus 4 squared plus 126. From this, we can find that our vertex coordinate is 4 and 126. The 4 represents our x coordinate, and the 126 represents our y coordinate, showing that the ball reached its max height of 126 meters at 4 seconds. Remember that when we take a number out of the bracket, it's always going to be the opposite sign. That answers the first part of this question. What about when it asks, when does the ball reach a height of 40 meters? Well, remembering our original equation, h of t equals negative 7t squared plus 56t plus 14. H of t really just means the height. And since we're being told that the height is 40 meters, we can just plug in 40. From here, we can bring the 40 onto the other side of the equal sign to make it negative 40, and 14 minus 40 is negative 26. From here, we now want to isolate for t to figure out at what time or times the ball is going to be at 40 meters. To determine t, we're going to be using the quadratic formula. Forget factoring, don't waste your time. And so t equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Negative 7 is our a value, 56 is our b value, and negative 26 is our c value. So then this makes our equation negative 56 plus or minus the square root of 56 squared minus 4 times negative 7 times negative 26 all over negative 14. We can simplify what's inside the square root to 2,408, and so now we can find our two possibilities for t. First, t is equal to negative 56 plus the square root of 2,408 divided by negative 14. This gives us about 0.49, and t can also equal negative 56 minus the square root of 2,408 divided by negative 14 to give us 7.5. Now from what I can see, both of these answers seem correct, as neither of them are negative, which would make sense, seeing as time cannot be less than 0. They fit within the time parameter, being 8 seconds, and of course from the diagram you would already know that there would be 2 points on the graph where the ball would be at 40 meters, seeing as it was kicked up from 14 meters, went all the way up to 126 meters, and then came down one more time, passing 40. Now for our final statement, we're going to want to write, therefore, the vertex of the ball is 126, and it reaches 40 meters at about 0.49 seconds and at about 7.5 seconds. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing, as it shows me that you like what you see, which helps me post more videos. Anyways, that's all for now. I hope you have a wonderful day.